Okay, thanks everyone. So I'm going to try and talk to you today and give you a demo on HashiCorp Nomad. So I've got a lot to cover. I'm going to try and be really quick and get to the demo. My name's James. I'm a principal engineer at Elsevier. I work in the core engineering team. At Elsevier, we've got around 100 different development teams, and they're all different products. They're very distinct. We have 30 million users. And within the company, there's about 7,000 people, about 1,000 technologists. Within the core engineering team, we are responsible for building reusable, secure, repeatable, kind of takeaway pieces of infrastructure. So if you've seen any of my talks before, it's about how we use Terraform modules to create repeatable infrastructure. And I'm going to quickly try and dive into what we've been doing with Nomad over the past 2 to 3 months. So to start off, I'll give you a brief overview of our requirements. So before we start any big project, we go through a requirements phase that we meet with our stakeholders, which are development teams, product owners, stuff like that. So it makes sure that we build a solution that's fit for purpose, that can be used by as many people as possible, and just has the right functionality. We don't build something that's brilliant, but unusable. So I'm going to go through the high-level requirements that we have. And the first is probably the most challenging one for us. Every development team must be able to run their own cluster, container cluster. So that's 100 development teams. They must be able to run their own cluster. Quite challenging. Each development team is likely to have 2 to 3 clusters, depending on their environment. So we had to try and figure that into it. It must also fit into our existing framework and methodologies. We operate a take it or leave it policy. So teams can use our stuff, they don't have to use it. So they can use our Terraform modules to create their VPC. If they don't, if they want to use our container cluster, they still have to be able to use that even if they're not using anything else. So a challenge there. And flexible and allow for customization. So what we build is probably not going to suit everyone's needs down to the ground. The largest teams in particular, they're probably going to want to make some customizations to the framework or the platform. So we have to make it so that components can be swapped in and out. We don't have large dependency chains, so if we're using X, that can't rely on having Y and Z. We have to make it very distinct, very clear. Alongside that, there's a huge plethora of technical requirements, APIs, UIs, routing, rack awareness, so on. There was a lot of meetings about it. And so what was the solution? So we did a proof of concept between Kubernetes, Mesos, and Nomad. Surprisingly to some, maybe, Nomad came out on top. Kubernetes came second, a very close second. The limiting factor was its operational complexity. We didn't feel that we wanted to run, well, there was no way to run and support 50, 100 different clusters in our environments. That would have been a bit too difficult. And Mesos came a pretty distant third. Quite disappointing. I don't know if anyone uses Mesos here. It's probably quite telling. But for us, so Nomad and Console, it's the tip of the iceberg. There's a lot more that goes on underneath for us. We use Terraform to deploy all our infrastructure. Everything gets done through Terraform. In the same way, our container cluster is built as a single module. You just run Terraform, it will build all the infrastructure it requires. No changes needed. We use Puppet, somewhat against my liking. We use Puppet to bake our AMIs. We also use Puppet to do bootstrapping of runtime information. So we use it at both stages. We partly bake the AMI just to make bootstrapping a lot quicker. It works for us. We have custom scripts and custom Go daemons. They are just to really make it kind of a production-worthy environment and a setup. We use Bash and Shell mostly for the kind of backup and restore. We have custom Go scripts or daemons that do advanced health monitoring, self-healing of the cluster, and also autoscaling, which is pretty cool. Out of the box, we use Fabio. If anyone's used Fabio, it's a great router, has native support in console. You deploy it, it goes easy. But again, we run that as a job on the cluster. So if you don't run the job, you can use something else. You can use something like Lyft's Envoy. You can use HA proxy with console template. So that's where we get into the kind of swapping out of parts. Jenkins, Elsevier pretty much a Jenkins house. So we have a default kind of example pipeline using Jenkins to deploy the jobs. Again, it's not to say that you have to use that. You can use GoCD, you can use more complex things like Verizon's Nelson. So again, it's a swappable part of our cluster setup. And obviously Docker's there, because why not? And so what does that result in? So an easy and fast to deploy cluster. We can deploy a cluster in 4 minutes. I am now going to do it because you don't want to see Terraform scrolling across my screen. So I'm going to run Terraform. So to prove I'm not doing some smoke and mirrors, that's my Amazon account, and there's nothing in there apart from some Jenkins and some Puppet. And here I am going to run some Terraform. So that's the plan. That was working earlier, because you can see all my commands. Pretty much. If not, I know where it is. Yeah. It's because I have all my aliases not working, apparently, right when I want them to be running. So, okay. So this is just to show I'm not lying about this. We're going to go from no cluster to an actual cluster. And my colleagues are going to love this, that I messed up on the exact first command I had to run. So are
you just creating the plan first?
So that's the plan.
Okay.
So that is just to show that I'm actually building 61 different things. So the Terraform will build everything the cluster needs to run: security groups, IAM roles, ELBs, ASGs, everything it needs to go. SSM documents as well, everything. There is literally nothing there. I'm going to apply that. Now it's going to go and spout a load of crap that's going on. All right, cool. So we're running. So I'll go back to presentation. By the time I've finished, we'll go into demo, and that should be up and running. So easy and fast to deploy. I've timed it at 3 minutes 50. So I'm going to deploy now three servers, 2 worker nodes. It scales linearly, so I can deploy hundreds worker nodes in the same time. There's no difference there. Complex functionality is presented really simply. One of the things that we try and do is make it really easy for people to use our tooling. So in this deploy, there is nothing more complex than a Terraform module and a bit of Puppet code. But what you actually get is quite nice. You get the advanced health monitoring and the cluster self-healing from our Go daemons. You also get the autoscaling, which does both cluster autoscaling and job autoscaling. So you can run different environments, you can run closer to the line, you can autoscale all your jobs. That was a big requirement for being production ready. Simple deployment pipeline, as I said, using Jenkins. It's an existing tool, so people don't have to do a lot of work to use it. Zero downtime, rolling upgrades of all the binaries on the cluster. So both the server and the agent nodes, we've got scripts, and we use SSM documents to manage upgrading all of them without impacting the cluster at all. Cluster and application alerting is done through PagerDuty. So if your application, your job running is having a problem, that can go out to PagerDuty. The same is said for the scaling. So we have AWS monitoring around all the kind of metrics you get there. Also, the auto-scaling daemon, if it's having problems scaling the cluster or jobs, that will alert to PagerDuty, so an ops person can actually figure out what's going on. And a full backup and disaster recovery strategy. That's what we do the bash scripts for. We just back up all the information we can, put it in S3, and we can actually bring a cluster up really quickly using that. Highly resilient, stable, fault tolerant. Nomad and Console give you that quite easily for free. I've played with it. I've tried to beat it up quite a lot. It's pretty stable. With some of the configuration that we do, I've spent half a day trying to break it, and it actually annoyed me how hard it was to break. And we can suffer multiple node failures. With the autoscaler, we use tunable algorithms to make sure that you can suffer node fault tolerances, that you have enough room to scale your jobs. So we make sure that it's production ready for you. And even in a single region setup, because everything's in code, if your region goes down, you've got the backups, you've got your Terraform, you've got your Puppet, you can lift it to another region, and you can deploy it in 4 minutes again. So pretty nice there. So now I'm going to try and put my money where my mouth is. We're going to go back, we're going to try and find a cluster that's actually running. And then I'm going to just demo a few of the kind of things that we've got, some auto-scaling, job deployments, see how it works. So this is where you cross your fingers and hope that I've not broken everything in Amazon. So if I refresh that, sweet. So we've got all our container servers. If I actually search, that'd be a bit better. So we've got 3 servers, 2 agents. So I'm going to go and jump on one of them. See, that's aliased and the other one isn't. I don't know why. No. Can everyone see it okay? Yeah. Okay, that's good. So if I do console members, we have 3 servers, 1 client, so maybe the other one's coming up. If I look at Nomad server members, we've got our 3 servers. And if I look at the Nomad node status, we've got 1 node ready. I'm going to go and check on the other one. So that was 12. Okay, I think it's just coming up. So we'll go on to the master. Damn it. I've done this a million times, it never breaks. Jesus Christ. The one time when I ran the script earlier. Right, okay. Now let's see how fast I can do things. All right, fine. I hate Puppet. I hate it. Who does use Puppet here? Does anyone use Puppet here? Yeah, okay. Who loves Puppet? Actually, that's a good question. No one loves Puppet, fine.
I reached it and I reached Chef and I'm going to ask you like that.
Yeah, I still don't like writing things. I don't writing my configuration in YAML. I find that unnatural. Okay, right, so. Right, we actually have a lot of servers now, good. So the first thing I'm going to do, now I'm going to have to rush through this. So we use Jenkins to deploy our stuff. So I am going to deploy Fabio, which is the router that we're going to use. If you've used Fabio, if you haven't, it is really great. So all the Jenkins job does, it uses a Docker container on the Jenkins master that runs the Nomad binary. With Nomad, you can use HTTP address flag, and we use that to point to the API of Nomad when we interact with it in that way. And so that is just going to fly along. And I need to go on that one. And if we look at a Nomad status now, you'll see that Fabio is running. Easy. So we run Fabio as a system job. That means that the scheduler will manage running that on every worker node in the cluster that matches the attributes and it can fit. So if we bring a new node into the cluster, the scheduler will automatically run that on the node. We don't have to do any work. It's really nice how it manages that across. So the next one we're going to do, so now we've got an actual load balancer running. We're going to deploy our CE app. So our CE app is just an example Go binary, just an example web server. Doesn't do anything clever at all. So I'm going to deploy a 1.0 version of it. And so I'm going to deploy 12 of it, which is actually too much for our 2-node cluster. So I'm going to try and invoke some actual cluster scaling. We'll see how quick it gets picked up. If it gets picked up, seeing how this is going, it might not work. So again, job's just going to go away. You can do more clever stuff around this. So the job will run a plan. It runs a syntax validation. It runs a plan further up. You can actually put like a Boolean check around that. So that an operator, before they deploy, they can actually check what they're doing. So we've gone and deployed 12 of that CE app. So if we go back to our cluster, we've got 12 running. So it's really quick, really responsive, really easy to pick up. So now if we look at our daemon log. So this is replicator. This is the autoscaling daemon that's running. Highly tunable. You can make it bend to your will. And so if you can just see at the bottom, I'll try and bring it up. So what replicator will do, it will assess the actual allocated resource. We don't care if it's not using that because the scheduler won't be able to schedule any more jobs. So we assess the resource, we assess the jobs running, we want to take into account fault tolerance, we want to take into account that we might want to scale that job. So then Replicator will actually make a decision and say, okay, I need more resource in this cluster. And what it will do, it will actually go out to Amazon and it will say, okay, put another node into that cluster. And so if I go to the Amazon console, so all it does is it increments the ASG count.
So, for example, you have a job and it requires X amount of compute and say 64 gig of RAM.
Yeah.
But that can only also run.
Yeah, so that's the thing. So the schedule at the moment, so this is the 001 version. It doesn't take into account that. So what it would do, the next run, it's got a cooldown period on it. So you can set the cooldown to nothing, and it evaluates every 10 seconds. So eventually it will catch up. We don't do that at the moment. So if you're going to run a job that needs a huge amount of resources, it's at the moment it's more up to you to go, okay, I know I'm doing this, let me increase the cluster size. We'd like to put that in, but we're trying to get some basic functionality in. So I'm going to check how long I've got. Close. So what we should be seeing now is the new node coming in. So yeah, it does all of that. Let's not wait for that, actually, because that would be boring. So I'll show you some job scaling as well. So to configure job scaling, we use console key value pairs. It's just a JSON blob. It works pretty much exactly like Amazon autoscaling. Min, max, scale on this CPU percentage, or mem, or scaling on that percentage. So, and as you see, it picks it up dynamically, and it will start scaling the CE app in. Because it's not using resources, it's below the percentage that we put the threshold in. And so it evaluates every 10 seconds. That's configurable. You can make it evaluate every second if you really want. And it will just keep scaling the app in by one. And it will just keep going. And Fabio is the load balancer in front of all of this. Is dynamically picking up on console's notifications and its service health checking. And so it completely stops routing to these back-end layers as soon as they go out of service. And it will keep going down. Every 10 seconds, we're going to decrement it by one. And if I go to here, you'll see that we've got 4, 3, and after 10 seconds, go down to 2. So that is enough of me bumbling doing a demo. So that's kind of the quick overview of what we've done. I do this demo to work at people where it usually takes a bit longer. So if you want to hear about any more stuff, come and grab me, have a chat. But that is what we've been doing at the past 2 months at Elsevier. We're going to continue working on that. And thank you for listening.